5 alternative theories to the Big Bang Theory. 5. Plasma universe theory. First up on this list, we have the plasma universe theory. Now, while standard cosmology holds gravity as the main guiding force, plasma cosmology, also more commonly known as the electric universe theory, instead places a much larger emphasis on electromagnetism rather than gravity. One of the earliest proponents of this theory dates way back to 1946, when Russian psychiatrist Immanuel Velikovsky wrote a piece on the theory itself, which he titled "Cosmos Without Gravitation," which argued that gravity is an electromagnetic phenomenon arising from interaction between atomic charges, free charges, and the magnetic fields of suns and planets. Now, while this theory was an intriguing one, it didn't have much validity to it, really, considering it to be a viable theory. This theory, though, however, was explored and developed even further in the 1970s by Ralph Jurgens, who claimed that the stars that we see are actually powered to light up by electrical rather than thermonuclear processes. Throughout the years, though, more and more theories and findings have developed to the point where it is now a potential viable theory. Many of these plasma universe theories tend to mention that the sun and stars are electrically powered by drift currents. On top of this, it mentions that these drift currents on some planetary surface features are caused by super lightning. As well as this, it's apparently said that the comet tails, Martian dust devils, and the formation of galaxies are all electrical processes. The theories claim that deep space is permeated with giant filaments of electrons and ions, which twist due to electromagnetic forces in space and create physical matter like galaxies. Plasma cosmologists assume that the universe is infinite in both size and age, which has limited its usefulness to creationists, despite its opposition to Big Bang cosmology. When it comes to this theory as a whole, one of the most convincing pieces of print when it comes to proving this theory is The Big Bang Never Happened. This book was written by Eric J. Lemur back in 1991. Lemur puts forward a very well put together argument that the Big Bang Theory incorrectly predicts the density of light elements like deuterium, lithium-7, and helium-4, that the voids between galaxies are too vast to be explained with a post-Big Bang time frame, as well as the fact these distant galaxies have the surface brightness that has been observed as constant, whereas in an expanding universe, the brightness should decrease with distance due to redshift. To round off his theory, he also claims that the Big Bang itself requires too many hypotheticals, such as inflation, dark energy, and even dark matter, and violates the law of conservation of energy, as it has the universe emerging out of nothing. When comparing it to the plasma universe theory, however, it's almost a complete polar opposite, as he argues that the plasma theory correctly predicts the abundance of light elements, the macroscopic structure of the universe, and the absorption of radio waves being the cause of cosmic background radiation. Now, while this theory is a fascinating one, it must be said that it's gained quite a bit of controversy. Many cosmologists have since gone on to argue that Lemur's criticisms of Big Bang cosmology are entirely based on notions that were known to be incorrect when he wrote the book, and his explanations of observations that back up Big Bang cosmology cause more problems than they can solve. 4. Chaotic inflation. Now, here's where things get interesting. So back in the 1980s, Stanford physicist Andrel Linde had some very interesting questions in regards to the Big Bang Theory that simply couldn't be answered. A lot of the questions asked by Linde were brought up in a 2007 issue of the Stanford Alumni magazine. The article these questions were brought up in was titled, "What Banged? Why Did It Bang When It Did? And Seemingly Everywhere at Once? What Existed Before It Banged?" The Big Bang may not have been a single event, but rather a scattered and irregular inflation, according to Linde. As previously stated, Linde began developing his chaotic inflation theory back in the 1980s. This theory consists of expansions like that of the Big Bang could happen at any point in space where the right potential energy is available. Linde would say that, quote, "We assumed that the entire universe was created at the same moment. However, it wasn't. Following his research, studies of the CMB that followed his initial findings in the 1990s showed variations of intensity, providing some supporting evidence for the chaotic inflation theory. Lind would continue to say that when viewed from much broader perspective, the cosmos does not fit into the framework science has constructed. He would continue by saying that, quote, "Instead of a universe with a single law of physics, eternal chaotic inflation predicts a self-reproducing, eternally existing multiverse where all possibilities can be realized. Parallel lines can intersect far enough away. The laws of physics can change. We just can't see it when they do. We're ants in a vast balloon." Needless to say, this theory holds a lot of validity to it and does make a lot of sense. However, until further, more physical evidence is provided, this is still only classed as a theory, albeit a really intriguing one. 3. Cold Big Bang and contracting universes. So it's pretty common knowledge that the Big Bang we've all come to know came about after all matter exploded out of a singularity. We all know that, and if we didn't, this video would be pretty awkward. The Big Bang occurred, which then ballooned into a hot and dense universe, and then began to slowly expand for billions of years. Now, unfortunately, the singularity is a bit of a problem, as it is quite difficult when trying to fit it in with the theory of general relativity and quantum mechanics. So cosmologist Christoph Wetterich from the University of Heidelberg has instead gone out of his way to argue that the universe may have begun as a cold and largely empty place, which has only become more active because it is contracting, rather than expanding, as in the Standard Model. According to him, in this model, the redshift observed by astronomers may be caused by an increase in the mass of the universe as it contracts. Light emitted from atoms is determined by the mass of particles, with more energy appearing as light moving toward the blue spectrum and less energy moving toward light in the red spectrum. Now, much like with all the theories on this list, despite being intriguing and even plausible, it does run into a major problem that proves that more research needs to be done, or that the theory has simply been debunked. The main problem with Wetterich's theory is that it's impossible to prove through measurement, as we can only compare ratio of different masses, not the masses themselves. One physicist even went on to argue that the model is like arguing that instead of the universe expanding, the ruler we are measuring it with is shrinking. Now, fortunately, the man behind this theory, Christoph Wetterich, has gone out of his way to claim that his theory is just that, a theory. It wasn't supposed to be a replacement of the Big Bang as we know it, but simply just an observation of the universe as well as a potential explanation that is more natural than what we know the Big Bang to be. 2. Tired light theory. Next up, we have the tired light theory. Although not as popular as the previously mentioned plasma universe theory, the tired light theory is yet another intriguing take on how the Big Bang took place and how the universe is what it is. The theory was first thought up by Edwin Hubble after he had observed wavelengths of light coming from a distant galaxy that had apparently shifted towards the red end of the spectrum compared to the light that was being emitted from stellar bodies that were in close proximity. This discovery, and research following, suggests that the photons had lost energy somehow. This redshift is generally explained in the context of a post-Big Bang expansion as being a function of the Doppler effect. This theory dates way back to 1929, as it was first proposed by Fritz Zwicky. His studies show that proponents of steady-state models of the universe instead showed that photons of light lost energy gradually as they traveled through space, moving to the longer wavelength, less energetic red end of the spectrum. There are a variety of problems with tired light. First of all, there is no way that a photon's energy could be charged without also changing its momentum, which would result in a blurring effect that we don't observe. Secondly, there is little to no explanation when it comes to the observed patterns of light emission from supernovae. Instead, it more closely matches the models for an expanding universe with special relativity causing time dilation. Last and certainly not least, most of these models for this theory are completely based on the notion of a non-expanding universe. As you know, this would lead to a background radiation spectrum that doesn't match our observations. by the numbers, if the tired light hypotheses were correct, all of our observed cosmic background radiation would have to come from sources that are closer to us than the Andromeda Galaxy M31, our closest neighbor galaxy, and anything beyond that would be invisible to us. It's an interesting theory, no doubt, but it definitely doesn't seem plausible. 1. Mirrored universe theory. Here's a theory that plenty of sci-fi fans are going to love, as this may be the most interesting theory of all, the mirrored universe theory. So one of the main problems when it comes to the laws of physics is the fact that almost all accepted models, including gravitation, electrodynamics, and relativity, work equally well at describing the universe, regardless of whether time is going forward or backward. In the real world, we know that time only goes in one direction, and the standard explanation for this is that our perception of time is merely a product of entropy, in which order dissolves into disorder. Now, while all of this seems to hold together, the main problem with this theory is the fact that it suggests that our universe didn't start the way we know it, but rather that the universe began in a high state of order and a low state of entropy. Strange, we know. With an outrageous claim like this, many scientists are unsatisfied and even annoyed with the notion of a low-entropy early universe fixing the direction of time. Since then, a collaborative effort from multiple established scientists from around the world have come together to develop a theory that suggests that gravity caused the direction of time to flow forward. This collaborative team extensively studied a computer-generated simulation of 1,000 point-like particles interacting with each other, influenced by Newtonian gravity. Their findings showed that regardless of their size or amount, the particles could eventually form into a low-complexity state of minimum size and maximum density. Following this, it was discovered that the system of particles would then expand in both directions, creating two symmetric and opposing arrows of time, and creating more ordered and complex structures on two paths. In conclusion, this theory would suggest that when the Big Bang occurred, not only did it create the universe that we now live in, but at the same time it also created a second universe, each of which has time running in the opposite direction of the other. Now, while this theory is interesting, I mean, the idea of there being two universes with time going the opposite direction to one another is sci-fi genre gold. I wouldn't be surprised if there was already a film or a TV series using this concept in some form. This two-futures situation would exhibit a single chaotic past in both directions, meaning that there would be essentially two universes, one on either side of this central state. If both universes were complex enough, both sides could sustain observers who would perceive time going in opposite directions. Any intelligent beings there would define their arrow of time as moving away from this central state. They would think we now live in their deepest past. Thank you for watching. Be sure to check out our previous videos and to subscribe and tap the bell icon so you'll be notified about future content. Be sure to also leave a like if you enjoyed the video and drop a comment down below. See you all soon.